Students of M.Sc Chemistry from semester 1 and respected listener, a very good evening and welcome all of you to today's lecture. Students of M.Sc previous chemistry from semester 1, I will teach you about the topic I have mentioned on the blackboard titled as Basic Fundamental and General Introduction of Chemical Dynamic, I mean to say CD, and that is of methods for determining of rate law with that is of collision theory. The given topic actually selected from that is of M.Sc Chemistry from semester 1, chosen from that is of unit 3 titled as that is of Chemical Dynamics from paper 3 Physical Chemistry. Today's lecture is very special and outstanding for the various competitive examination of NET, JRF as well as that is of various examination conducted by that is of M.Sc previous from paper 3 Physical Chemistry and its various examination. Students of M.Sc Chemistry from semester 1, today's lecture is further divided into its that is of two first part. First one part that is the general introduction of CD chemical dynamic, and second part that is of collision theory of that is of rate law. So first of all, it becomes essential I would like to explain to deliver today the basic concept and general introduction of that is of chemical dynamics. Here I bring to draw your kind immediate notice on our last video in which we were defining, expressing about that is a fundamental definition of order of reaction and that is of molecularity. Once again I repeat about the essential definition, fundamental facts about that is of order of reaction, that is of molecularity. Here students of M.Sc Chemistry from semester 1 of paper 3 Physical Chemistry, that order of reaction one can define that total number of living species, active species, molecular species, atomic species whose total number to give to influence to affect the velocity of the reaction, such total number are known as that is of order of reaction. On the other hand, molecularity to give the total number of that is of active and inactive neutral molecules whose total appearance presence to define the stoichiometry of the reactions. Here students of M.Sc Chemistry from semester 1, the distinction, the difference between order of reaction and molecularity can be explained by using a fundamental our daily to daily routine life. Once again I explain, I will explain about order of reaction and that is a molecularity, and how does they play an extreme role to explain the progress of the reaction in that is of chemical dynamics. Here it can be explained by consideration a simple interested example which is associated with that is of our daily to daily routine life. There are two types of the persons or students in our that is of a society or social life. First types of the persons are those who are dedicated, sincere, and they perform their duty with dedication, sincerity, with that is of active way. Such total number in the society one can classify into that is of order of reaction. On the other hand, second types of the persons are those who are not sincere about their duty, inactive, they are neutral, means their presence about their that is of duties and their mission, their goal. There are such numbers inactive, that is of inert persons, total there such numbers are known as that is of molecularity. I mean to say here that is in the same sense, in the same manners that is of two types of the persons existing in our society, active and inactive, in other words that is of dedicated or neutral. So in the same series there are so many reactions are undergoing in the whole extended environment of that is of chemistry, in which first types of the reactants are those who change the velocity of the reaction, concentration of the reactions, and to influence the velocity of the reaction there are such total number of numbers, species, active species, molecular species to give the value of that is of order of the reactions. Here Order of reaction can be that is further expressed into the further kinds of that is a first order reaction, second order reaction, third order reaction, zeroth order reaction, and fraction order of the reactions here. On the other hand, molecularity to give the total number of inactive, active molecules, atomic species, molecular species, whose total concentration to determine the that is of stoichiometry. Now question is now raised here. Since you know in various example, various questions set, there are the why such appearance of the molecules who their inactive appearance, why we should not, why we don't eliminate such reactions. So obviously it is very simple answer. Students of M.Sc chemistry from semester 1, we cannot eliminate such that is of inactive species, because suppose we eliminate such reactants, so I mean to say the stoichiometry for reactant and products will be unbalanced here, so it becomes essential, will be disturbed here. Stoichiometry, the strength number of moles will be totally unbalanced, stoichiometry will be totally disturbed here. So equal order of reaction and molecularity both to play an extremely role at their contribution to explain the progress of the chemical reactions. Now I will deliver today a very special topic here, titled I have mentioned on the blackboard in the same series, order of reaction, molecularity. Third one I would like to define, I will like to deliver today on that is a pseudo order of reaction in the series of that is of general introductions here. Pseudo order of reaction, it is evident from that is of pseudo means to develop the dual nature in our mind, to become that is of confused state, suspension condition, the decision we are unable as we think just reciprocal results are produced here. For example, to explain that is a pseudo here, once again we think there are so many reactions are known. Generally it is the fundamental theory of chemical dynamics, normally order of reaction and molecularity to possess the same value. I mean to say first order of reactions means to possess that is of unimolecular reactions, second order of reactions to possess that is of bimolecular reaction, and third order of reactions to possess that is of trimolecular reactions here. But on the behalf of the nature and on the behalf of mechanism, it has been observed that order of reaction and molecularity are produced or observed in different way. In other way, that is of pseudo order of reaction are those reactions in which order of reaction and molecularity are the difference here. Here, that is the normal concept regarding to that is the order of reaction and molecularity I have mentioned on the blackboard. Normally, the fundamental theory that is of order of reaction, that is of molecularity are the same. But on the behalf of the nature of the reactants and on the behalf of the mechanism, there are so many reactions which are undergoing more than one step with on the behalf of two factors who are responsible to give the different value between order of reaction, that is a molecularity. Such reactions are that is a pseudo order of reaction, as we think just our opinion, the reverse opposite results order of reactions are calculated here. As first of example, I would like to explain to you my question to all of the students of M.Sc previous chemistry. The thing which is I have caught in my hand, what is your opinion, what is your response about this thing? To explain that that is a pseudo term. Pseudo means that is of to create, to develop in that is of confusion position, in that is of suspended dual concept. We are unable to decide, as we think just reverse result, just that is of reversible, that is of reverse result are produced here. My question to you, what is your opinion about this? I rotate this, that is of forward direction, backward direction, upward direction and downward direction. Once again I rotate the thing which is I have caught in my hand, forward direction, that is of in backward direction, upward direction, and that is of downward direction. So you respond that it is that is of duster. So it is exact answer that is that is a shoe shiner. So our opinion that we observe the thing that is it must be that is of a duster, but on the other hand, it has been by that is of various experimental test, it has been that is of confirm it is not a duster, but it is that is of shoe shiner. The pseudo means that is of here, that is just reverse, opposite, just reverse result actually have been performed, have been produced here. So such conditions, such reactions are known as we think the order of reaction that is of 2, but order of reaction are different to that is of molecularity. One important example I have mentioned on the blackboard, hydrolysis of that is of ethyl acetate. Second one, that is of inversion of that is of sucrose here. Our opinion in both the equation, the order of reaction in equation number first of all we check. In equation number 1, that is of order of reaction should be that is of 2, because 2 molecules are present here. Ethyl acetate 1 molecule, next one that is of H2, but the order of reaction is that is of 1. Similarly, in next phase, the inversion of that is of sucrose with hydrolysis of that is of sucrose to give 1 mole of glucose, and that is 1 mole of that is of fructose. My question in question number 2, what is the order of reaction? So I obviously, as we think our judgment that is the order of reaction must be that is of 2, because 2 molecules are present as our normally common fundamental theory. But due to in both the 2 important example reactions, due to the that is of H2 in excess concentration, it the changing the concentration of bulk concentration, excess concentration of H2 does not measurably change here, or in other words we can say the excess concentration of H2O doesn't affect the velocity of the reactions here. Hence the velocity depending upon in both the case in equation number 1 the low concentration and unity concentration of ethyl acetate here. Similarly, in the case of next one, inversion of sugar, due to the bulk excess concentration of H2O, its concentration doesn't measurably change here. The concentration depending upon the initial and unity power that is of inversion of sugar, that is of C12H22O11. The first factor now raised here, first factor now clear here. First of all, I would like to define about here order of reactions are those reactions in which order of reactions pseudo order of reactions are those reactions in which order of reaction and molecularity are the different, and it has been proved, it has been that is of experimentally verified on the behalf of 2 important factors. The order of reaction and molecularity are found in different way. First one, that is of the nature of the reactant which is present in that is of excess concentration here. Its bulk concentration doesn't influence the velocity of the reactions here, as we have delivered in 2 cases. First one, hydrolysis of that is of ester. Second one, that is of inversion of sugar here. Second one, factor which is responsible to give the pseudo order of reaction, that is the mechanism here. Mechanism, its kinetic I will deliver to you in the next coming lectures here, but I will teach you about the basic fundamentals of first factor, in which due to the one reactant which is present in excess concentration here, its excess concentration here, the changing in its concentration in both the two conditions, 2 equations, due to the excess concentration of H2 does not measurably change here. In other words, we can define the H2 in present in excess concentration doesn't affect the velocity of the reactions here. Now second one, so the order of reaction and molecular are different here. In 2 cases here, finally the result I have mentioned here. In equation number that is 1 and 2, order of reaction that is 1 with respect in equation number 1 depending upon low concentration of ethyl acetate, and that is of molecularity that is of 2, because H2 1 molecule is present here and ethyl acetate second molecule, so total 2 molecules mean equation number 1 that is a bimolecular reaction. Next one, that is of inversion of that is of sucrose, which is undergoing by means of hydrolysis of that is of H2O. In second one case here, that is of sucrose 1 mole, next one H2 molecule, total to give the value of bimolecular reaction. Now next one questions our that is of how will you write down the rate equation or rate law for these various 2 important questions. Students studying admitted M.Sc chemistry chemistry, but they don't know how to write down the expression of rate law and rate equation. The students of M.Sc chemistry from semester 1 of physical chemistry, very simple. For reactant, you have to write down that is a negative sign, with that is a mathematical operation with changing of d by dt here. In the case of equation number 1 here, minus d by dt here, and CH3COO2H5 is earlier as beginning you have to write down overall that is of the reactant, in which initial reactant directly proportional here. So it becomes essential to write that is of rate law exactly here. Minus d by dt CH3COO2H5 is directly proportional to, you have to write the initially both the concentration in the form of that is active mass here. In equation number 1, yes, CH3COO2H5 active mass now will be multiplied, that is of next one is to in beginning of the reaction, while writing exactly the expression of rate law rate equation, it becomes essential to write down the complete reactant in terms of active mass. Next one, minus d by dt CH3COO2H5 here, that is of, in order to remove a proportional we require a constant. I write here that is of K, and that is of H2O, and that is of active mass of CH3COO2H5, its concentration of 1. Here it must be remembered here, right hand direction here, you have to write down all the reactant present in chemical reactions in the form of reactant, while you have to write down only one. And which velocity of the reaction, order of the reaction is depending upon that particular that is of reactant here. So obviously K is equals to K H2O CH3COO2H5. First order reaction, that is you have to write down that is unity power here. K constant here, H2O constant here, H2O constant, why H2O constant here, the active mass of H2 is constant here. Due to its bulk concentration, the multiplication of two constant, that is of K and H2 to give a new constant, and I name it that is of K1 dash here. K1 dash here means that is of the reaction, that is of K1 dash first order rate constant here. K1 dash first order O4O R4 rate C4, that is a constant. Order rate constant here. So K1 dash means first order pseudo order rate constant here. Suppose I eliminate, I remove that is of dash, so it becomes essential in such a reaction. Molecularity and order of reaction are the same, means that is unimolecular. Suppose I eliminate that is of dash, it will be purely independent first order rate constant, means the reaction that is of unimolecular to possess that is of first order of reaction. But in this case, hydrolysis of an students of M.Sc chemistry from semester 1, since order of reaction and molecularity are different due to the first factor, that one reactant is present to proceed that is of its dense concentration. So its dense concentration doesn't measurably change, doesn't influence the velocity of the reactions here. So it becomes essential for the distinction of K1 dash, and that is of K1. Here that is of K1 dash is CH3COO2H5. That is a unity power here. The K1 dash, that is pseudo first order rate constant, said that is equation number 3 here. So it is the method, exact method here. Similarly, one can write for that is of inversion of that is a sugar. Rate is directly is equals to K1 dash here. Dash means that is for it dash will be used here for that is of pseudo term here. So rate is equals to K1 dash C12 H22, that is O11 to the power that is of unity. So I mean to say it must be clear here. You have to define the that is of about pseudo order of reaction. Pseudo order of the reactions are those reactions in which that is of order of in which order of reaction and molecularity are found in different way. The number are found or in normally way, that is of pseudo order of reaction are those reactions in which order of reaction and that is of molecularity are different. Why that is of different value order of reaction and molecularity have been reported here? It is depending upon on the behalf of two important factors. First one factor depending regarding upon that is of one reactant is present in excess concentration, bulk concentration, dense concentration, and there are dense concentration doesn't influence the velocity of the reactions here. Second factor, students of M.Sc chemistry from paper 3 physical chemistry, the second factor which is responsible to define about pseudo order of reaction, that is the mechanism of the reactions undergoing in coming timing here. There are so many reactions in which order of reaction and molecularity are that is of different here. It is depending upon the mechanism undergo in various steps, except one rest steps undergo fastly. First step which is moving slowly to define the velocity of the reaction, to give the total account of order of the reactions here. Now allow me to join you tomorrow's lecture based on chemical dynamics. Now you take care. Now till then, thank you very much.